Okay, now we're going to look at the independent T. And the research question that we're working with is, to what extent do men and women differ on your assigned variable? For me, it'll be, to what extent do men and women differ on their final exam in the course? And the final exam will be designated as Test 15. Now, notice that we are in the independent T. We have one grouping variable, which in this case the grouping variable is called female, indicating that women are coded as a 1 and men are coded as 0. So there's one grouping variable and two levels, and only two levels of that grouping variable. So we have men and women. And our dependent variable is Test 15 for me. And I have the examined variables, and now I've included the by statement so that I can look at Test 15 separated out by men and women, and I get my statistics and charts for normality, so I can test that assumption. And then here is the syntax in order to test the independent T, and one of the things that you must designate is the group. And the group in this case is female, as we've said, and you have two numbers within there, the parentheses there, because that's designating what you've coded your variables at. I've coded my variables as 1 and 0. If instead you had coded your variable levels as, let's say, 2 and 3, then you would indicate 2 and 3 there. Whatever number you coded the men and the women, if you were using gender, then that's what goes in there. SPSS doesn't care. It just wants to know what to look for, what two levels within that variable are being tested. And there is the dependent variable in your variable list, and then there's the confidence interval. And the way you get this is to go through Analyze, Compare Means, Independent Sample T. And of course, when you click on this, you get a pop-up box, and the pop-up box will be labeled Independent Sample T, the same as the last thing that you clicked on. And what you'll do here is you'll take Test 15, and then you'll grab female from your list of variables over here, and you will place it into the grouping variable box. And then you'll see that when you place a variable into the grouping variable, and it should be a nominal variable, you will be asked to define the groups. And what SPSS is asking for again is, what number did you code them? So group 1, I put 1, group 2, I put 0. So in our case here, for the variables, group 1 is the women, group 2, which is the 0, is the men. And so, and notice, because how do you know that this box came from the defined groups? Well, SPSS names it the same thing. So that way you know that when you click on defined groups, you should get this pop-up, and that's where you indicate how you coded your variables. Then you hit continue, then you hit paste, and you should get this statement over here. Or again, it's much easier, instead of having to go through all that, to just type this in. Don't forget that SPSS requires that you have a period at the end. Sometimes when this doesn't work, people forget to put a period, or they forget not to leave spaces in the middle of names of variables. So Test 15 is all one word. There's no space in between there. Okay, so now that you have that and you've run that, you'll get descriptives, but instead of just getting descriptives for a single, for all Test 15 together with men and women, now you get it separated out. And in this case, remember, my 1 is my women, and so here I have the mean and the confidence interval for women, and then here I have the mean and the confidence interval for men. And you'll see, and I know it's men because it's 0 on the female, which means it's male, and you'll notice that their numbers, their average is different. For women, there was an average of 77.67 on the test, And for men, it was 78.59. So the men were a little bit higher than the women, but we don't know yet if that was statistically significant. First, we need to understand if we've met the assumptions to even do the test. So we look at the skewness and the standard error for the skewness and the kurtosis and the standard error for the kurtosis. And I wrote it out here and divided that out. And you can see that both of these values are less than 2, less than 3. 3 if you're being less conservative, 2 if you're being more conservative for the test statistic there, the standardized. And then I did the same thing here. The skewness divided by the standard error of the skewness, kurtosis divided by standard error of the kurtosis. And again, both of these values are well within the range that we expect them to be. But we also have our test of normality. And you can see that for the women, both the Shapiro-Wilks and the KS test came out to be not statistically significant. So that means that it's normal enough. It didn't violate the assumption. Whereas for the men, it seems like with the Shapiro-Wilk it still came out okay, but with the KS test it did come out statistically significant. But I've seen already for both the men and the women that these are still okay. So taken together, I would say this data is still fairly normal. And again, I like to look at the QQ plots. So if I look at the QQ plots, I can see, and again, this is for the men, and here's for the women, although at the tail we kind of have a little bit of a curvature there, but for the most part, this is fairly normally distributed data according to the QQ plot. So I'm going to proceed with my test. So this first part, remember, we were just looking at the information given by the examined variables, which we've looked at before. Remember, you'll get that within descriptive statistics and explore. So now I get my output for the independent sample T. And the unique thing about the independent sample T is there's actually 2 tests within here. First, in this section here, you have the Levene's test. And what this is the test for homogeneity of variance. And it even tells you that it's the test for homogeneity of variance. Right here it says Levene's test for equality of variances. That is one of the assumptions of the independent T, is that the variances of the 2 groups are equal. And so what Levene's does is there's a significance test, a hypothesis test, to see if they are indeed equal. And so in this case, the significance level is not for the t-test, that's over here. The significance level is for the equality of variances. And so for this one, you do not want it to be less than 0.05, because if it is less than 0.05, much like the normality test, when it's less than 0.05, that means it's violating the assumption when you're looking at the assumption test here. So we are glad that it's above 0.05, meaning that the variances are equal enough. As soon as you decide on that, then you are done with the Levene's test, and you can now assume equal variances, which what that means, or should mean to you in this case, is that you will work on this column only for looking at your results, because if you could not assume equal variances, then you would have to work in this column, or in this row down here. But because we did not have statistically significant Levene's test, we can work here. Okay, so now we're ready to find out the results of the t-test itself. And when we look at the t-test results, we look at the significance value, which is the probability p-value, which we compare to our 0.05, and we see here that this is greater than 0.05. In other words, the men and the women are not statistically significantly different. Although the men did score on average higher than the women, the difference was not statistically significant. Remember, we said that the men scored 78.59 and the women scored 77.67, but this difference was not statistically significant, and that's what tells you right there. And in addition, you have a confidence interval for that difference there, which you can see the confidence interval overlaps 0 if this was on a number line, which means that the difference between them could in fact be 0. So back to our research question: to what extent do men and women differ on their final exam in the course? Well, we know they do differ, but not statistically significantly different. So to what extent? So let's look at the effect size. And again, you use the Excel sheet that I provide for you within Blackboard, and all you need to do is put in your values for the two groups. So there's the men and the standard deviation for the men and the sample size for the men. There's the women and the standard deviation for the women and the sample size, which you can all get from your descriptives table. And then once you put those values in, you will get your Cohen's d, which is 0.18, which again is a standardized effect size, and your t statement can be written by looking at your independent samples t-table. Now remember, only because we could assume that the variances were equal because we did not reject the Levines, then we can stay on this row. If instead, if this value had been less than 0.05 for the Levine's test, then we would have had to use this row. Well, why does that matter? Because here we have 298, which is the degrees of freedom for this row. But if we could, for example, let's say your test results violate statistical significance and you have to use this value, notice the degrees of freedom are different, because what this is doing, we talked before about how one of the ways to handle heterogeneity of variance is that you use some kind of correction. Well, in this case, when you cannot assume equal variances, there's a correction in the number of degrees of freedom, and that's what that's doing there. So here we have 298 for our degrees of freedom because we are in this top row, and the negative 1.52, which is the value for the t, indicating that it's negative because indicating that the women are lower than the men, but the p-value indicates that this value is not statistically significant because it is greater than 0.05, and then the degree of that difference, or the extent of that difference in standardized units, is 0.18.